Central Processing Unit, CPU, principal part of any digital computer system, generally composed of the main memory, control unit, and arithmetic logic unit. It constitutes the physical heart of the entire computer system. To it is linked various peripheral equipment, including input/output devices and auxiliary storage units. In modern computers, the CPU is contained on an integrated circuit chip called a microprocessor. The control unit of the central processing unit regulates and integrates the operations of the computer. It selects and retrieves instructions from the main memory in proper sequence and interprets them so as to activate the other functional elements of the system at the appropriate moment to perform their respective operations. All input data are transferred via the main memory to the arithmetic logic unit for processing, which involves the four basic arithmetic functions, i.e., addition, subtraction, multiplication, and division, and certain logic operations such as the comparing of data and the selection of the desired problem-solving procedure or a viable alternative based on predetermined decision criteria. The Central Processing Unit, CPU, is the primary component of a computer that acts as its control center. The CPU, also referred to as the central or main processor, is a complex set of electronic circuitry that runs the machine's operating system and apps. The CPU interprets, processes and executes instructions, most often from the hardware and software programs running on the device. The CPU performs arithmetic, logic, and other operations to transform data input into more usable information output. While the CPU must contain at least one processing core, many contain multiple cores. A server with 2 hexacore CPUs, for example, will have a total of 12 processors. If you're just learning about the world of computers and electronics, the terminology used to refer to different parts can be confusing. One component term you may have encountered is CPU, which stands for Central Processing Unit. CPUs reside in almost all devices you own, whether it's a smartwatch, a computer, or a thermostat. They are responsible for processing and executing instructions and act as the brains of your devices. Here, we explain how CPUs interact with other parts of your devices and what makes them so integral to the computing process. The CPU is the core component that defines a computing device, and while it is of critical importance, the CPU can only function alongside other hardware. The silicon chip sits in a special socket located on the main circuit board, motherboard or main board, inside the device. It is separate from the memory, which is where information is temporarily stored. It is also separate from the graphics card or graphics chip, which renders the video and 3D graphics that are displayed on your screen. CPUs are made by arranging billions of microscopic transistors onto a single computer chip. These transistors enable the CPU to perform the computations necessary for executing programs stored in your system's memory. Functioning as tiny switches, they alternate between on and off states, conveying the binary ones and zeros that underlie all your actions on the device, whether it's watching videos or composing an email. In the context of modern devices, a desktop or laptop has a dedicated CPU that performs many processing functions for the system. Mobile devices and some tablets instead utilize a system on a chip, SoC, which is a chip that packages the CPU alongside other components. Intel and AMD both offer CPUs with graphics chips and memory stored on them, too, meaning they can do more than just standard CPU functions. At its core, a CPU takes instructions from a program or application and performs a calculation. This process breaks down into 3 key stages: fetch, decode, and execute. A CPU fetches the instruction from RAM, decodes what the instruction actually is, and then executes the instruction using relevant parts of the CPU. The executed instruction, or calculation, can involve basic arithmetic, comparing numbers, performing a function, or moving numbers around in memory. Since everything in a computing device is represented by numbers, you can think of the CPU as a calculator that runs incredibly fast. The resulting workload might start up Windows, display a YouTube video, or calculate compound interest in a spreadsheet. In modern systems, The CPU acts like the ringmaster at the circus by feeding data to specialized hardware as it is required. For example, the CPU needs to tell the graphics card to show an explosion because you shot a fuel drum in a game, or tell the solid-state drive to transfer an Office document to the system's RAM for quicker access. Originally, CPUs had a single processing core. Today's modern CPU consists of multiple cores that allow it to perform multiple instructions at once, effectively cramming several CPUs on a single chip. Entry-level processors today have between 2 and 4 cores, while 6 to 8 cores is more mainstream in gaming devices and PCs. High-end models can have anywhere up to 32 cores, and professional hardware can go beyond that. Many processors also employ a technology called simultaneous multithreading. Imagine a single physical CPU core that can perform 2 lines of execution, threads, at once, thereby appearing as 2 logical cores on the operating system end. These virtual cores aren't as powerful as physical cores because they share the same resources, but overall, they can help improve the CPU's multitasking performance when running compatible software. Clock speed is prominently advertised when you are looking at CPUs. This is the gigahertz, GHz, figure that effectively denotes how many instructions a CPU can handle per second, but that's not the whole picture regarding performance. Clock speed mostly comes into play when comparing CPUs from the same product family or generation. When all else is the same, a faster clock speed means a faster processor. However, a 3 GHz processor from 2010 will deliver less work than a 2 GHz processor from 2020, due to the newer model's more advanced underlying silicon. These days, your CPU isn't as important for overall system performance as it once was, but it still plays a major role in the response and speed of your computing device, and without one, it wouldn't work at all. Gamers will generally find a benefit from higher clock speeds, while more serious work such as CAD and video editing will see an improvement from a higher CPU core count. You should bear in mind that your CPU is part of a system, so you want to be sure you have enough RAM and have fast storage that can feed data to your CPU. Perhaps the largest question mark will hang over your graphics card, as you generally require some balance within your PC, both in terms of performance and cost. CPU is short for Central Processing Unit. It is also known as a processor or microporcessor. It's one of the most important pieces of hardware in any digital computing system, if not the most important. Inside a CPU there are thousands of microscopic transistors, which are tiny switches that control the flow of electricity through the integrated circuits. You'll find the CPU located on a computer's motherboard. A computer's motherboard is the main circuit board inside a computer. Its job is to connect all hardware components together. Often referred to as the brain and heart of all digital systems, a CPU is responsible for doing all the work. It performs every single action a computer does and executes programs. What are computer programs and where are they stored? There is a program for everything a CPU does. You have a program that lets you use your web browser or a word processor. You have one that performs mathematical operations on a calculator or lets you type letters and characters on a keyboard. And there are programs that manage clicking and selecting elements with a computer mouse and pressing down on your laptop's touchpad. Whatever it may be, there is a program for all computer activities. Programs are sets of instructions that need to be executed in sequential, logical order and be followed precisely step by step. They are written in a human-readable language, a programming language, by a programmer. Computers don't understand programming languages directly, so they need to be translated to a form that is easier understood. That form is called machine language or binary. Binary is a base 2 numerical system. It's comprised of only 2 numbers, 0 and 1. This reflects and ties in well with the only 2 possible states transistors have to control the ebb and flow of electricity. They are either on, 1, or off, 0. So, under the hood, programs are stored as sequences of bits. Bits are another name for binary digits, sequences of ones and zeros. Programs are stored permanently and long-term in a storage device, whether it's a HDD, hard disk drive, or SSD, solid-state drive. These are non-volatile types of memory, meaning they store data even when the power is off. While a program is up and running and currently being used, though, all of its data is stored in the main, primary, memory or RAM, random access memory. This type of memory is volatile, and all data is lost when the power shuts off. In a nutshell, a CPU is responsible for handling the processing of logical and mathematical operations and executing instructions that it is given. It can execute millions of instructions per second, but can carry out only one instruction at a time. It first receives some type of input, typically from an input device, such as a monitor display screen, a keyboard, a mouse, or a microphone, or from an application/system software program, like your web browser or operating system. Then the CPU is in charge of 4 tasks. Fetching instructions from memory, in order to know how to handle the input and know the corresponding instructions for that particular input data it received. Specifically, it looks for the address of the corresponding instruction and forwards the request to the RAM. The CPU and RAM constantly work together. This is also called reading from memory. Decoding or translating the instructions into a form the CPU can understand, which is machine language, binary. Executing and carrying out the given instructions. Storing the result of the execution back to memory for later retrieval if and when requested. This is also called writing to memory. Finally, there is an output of some kind, such as printing something to the screen. The process described above is called the fetch-execute cycle, and happens millions of times per second. Now you know the basic tasks a CPU performs for every operation happening on a computer. What are the parts of the CPU that help get that work done? Below are some of the important components within it. CU, short for control unit. It regulates the flow of input and output. It's the part that fetches and retrieves the instructions from main memory and later decodes them. ALU, short for arithmetic logic unit. The part where all the processing happens. Here is where all mathematic calculations take place, such as addition, subtraction, multiplication, and division, as well as all the logical operations for decision making, such as comparing data. Registers. An extremely fast memory location. The data and instructions that are currently being processed during the fetch-execute cycle are stored there, for quick access by the processor. Earlier you had that a CPU can typically perform just one action at a time. It executes one instruction at a time, and it does this with the help of physical cores. Essentially, a core is a CPU itself, a separate device inside the main CPU chip. This means that it has the ability to do just one thing at a time. However, modern computers have the ability to support more than one core inside the main chip. The more cores a CPU has, the greater the computational power and the more tasks that can be running and completed simultaneously, making the CPU a serial multitasker. For example, there are dual-core CPUs, meaning there are 2 CPUs on the same chip and can run 2 instructions at the same time. Quad-core CPUs mean there are 4 CPUs on the same chip, hexa-core CPUs mean there are 6 cores, and so on. Modern CPUs also support a technology called hyperthreading. The way this works is that a single physical core appears as multiple physical cores, making the operating system think there are more cores than there actually are. This in turn makes the computer think it has more power than it actually has. So, in addition to the physical cores mentioned in the section above, there are also these virtual cores, or threads as they are also called. They aren't actual physical cores, but they appear to be so. The combination of both physical and virtual cores make the execution time of programs even faster and give CPU even more computational power. The component of a computer system that controls the interpretation and execution of instructions. The CPU of a PC consists of a single microprocessor, while the CPU of a more powerful mainframe consists of multiple processing devices, and in some cases, hundreds of them. The term processor is often used to refer to a CPU. Central Processing Unit, CPU, consists of the following features. CPU is considered as the brain of the computer. CPU performs all types of data processing operations. It stores data, intermediate results, and instructions, program. It controls the operation of all parts of the computer. CPU itself has following three components: memory or storage unit, control unit, ALU, arithmetic logic unit, memory or storage unit. This unit can store instructions, data, and intermediate results. This unit supplies information to other units of the computer when needed. It is also known as internal storage unit or the main memory or the primary storage or random access memory, RAM. Its size affects speed, power, and capability. Primary memory and secondary memory are two types of memories in the computer. Functions of the memory unit are: it stores all the data and the instructions required for processing. It stores intermediate results of processing. It stores the final results of processing before these results are released to an output device. All inputs and outputs are transmitted through the main memory. Control unit. This unit controls the operations of all parts of the computer but does not carry out any actual data processing operations. Functions of this unit are: it is responsible for controlling the transfer of data and instructions among other units of a computer. It manages and coordinates all the units of the computer. It obtains the instructions from the memory, interprets them, and directs the operation of the computer. It communicates with input/output devices for transfer of data or results from storage. It does not process or store data. ALU, arithmetic logic unit. This unit consists of two subsections, namely: arithmetic section, logic section. Arithmetic section. Function of arithmetic section is to perform arithmetic operations like addition, subtraction, multiplication, and division. All complex operations are done by making repetitive use of the above operations. Logic section. Function of logic section is to perform logic operations such as comparing, selecting, matching, and merging of data. Thank you for watching this video.